So good morning dear cadets. With the continuation of oxides of nitrogen, today is N2O3. Okay, so nitrogen trioxide, nitrogen third oxide or dinitrogen trioxide, both way you can remember. This one is the stock notation. Third meaning of third is oxidation state of nitrogen is third here. Method of preparation, it is very simple method that nitric oxide you have to take. Now that should react with N2O4. So what here you will get N2O3. Balance the reaction. So if you balance, this is 2 and here also 2. Okay. So you will get the N2O3. Temperature should be 250 Kelvin. As far as the properties are concerned, you know, study only I told you this is known as anhydride of nitrous acid. Means from the two molecules of nitrous acid, if you remove one molecules of water, then you will get the N2O3. So this is the first physical property. Second one is it is blue color solid and acidic in nature. So already I told you N2O3, N2O4 and N2O5. These are the acidic oxides of nitrogen. Now the last one is the structure. Okay. So just try to understand. N2O3, total how many number of electrons should be there? N2O3 equal to 10 electron from nitrogen and 18 electron from oxygen. 6 into 3. So total 28 electrons should be there. And now you should make a structure in such a way so that the octet of each and every one atom which is present in N2O3 should be satisfied. So just try to understand. Around the nitrogen, how many electron is there? 5 electron. I am beginning with this nitrogen. So out of 5, 2 are shared here. Okay. 1 is shared here. So total is 3 and 2 these lone pair. So total 5 electron is there. Octet is also completed. 4 electron, 6 electron, 8 electron. Okay. Oxygen, 2 electron is shared here and 2 lone pair is there. So total here also 8 is there. Now come back to this nitrogen. This nitrogen has got 5 electron. Out of 5, 2 are shared here, 1 is shared here. Okay. So 3. Now 2 more electrons are there. Now according to rule of covalent bond, 1 electron should be shared by nitrogen and other electron should be shared by oxygen. Then this bond is formed. But here what is happening? This bond is formed by nitrogen only. So nitrogen both electron is included here. This oxygen has got the negative sign, negative charge. Okay. So now the total electron of nitrogen is 5. So 2 here, 4 and fifth one is here. So 5 electron is completely completed. And now their oxygen you can see. 2 electron is here shared. And the remaining 2 are, means lone pair is 2, 2, lone pair is here. So the octet is also completed. 4 electron, 6 electron, 8 electron, 2, 4, 4, 8. Here 2, 4, 6, 2, 8. So this is the stable structure. Okay. This is the resonating structure first. And now this is the resonating structure second. To get the resonating structure second, what you will do? Just shift this bond here. So now this oxygen will have now 6 electron. You can see clearly. And now see shift this bond here. So now here double bond would be there. In this way, what is there? These two structures are formed by the resonating structure is formed by the N2O3. Now as far as resonance hybrid is concerned, you can see, now just see, this is the resonance hybrid. What is this one? Resonance hybrid. In resonance hybrid, what is there? Everywhere I put single bond because after the shifting, each will have single bond only. But these bond length will tell you that all bonds are not equal. Like this NO bond, 121 picometer, while this NO bond is 114 picometer. What about this bond angle? 130 and this bond angle is 105 degree. So in this way the resonating structure of N2O3 is completed. Okay. Now the next one is N2O4, dinitrogen tetroxide. So N2O4 is the dimer of NO2. Okay. So first we'll teach you NO2, their structure. NO2 is stable in the gaseous state and 2O4 is stable in liquid and solid state. Okay, and NO2 is also odd electron molecules, because how many electron it will have? NO2. Total number of electron would be 5 plus 12, 17. So NO2 is a odd electron oxides of nitrogen. One more oxide of nitrogen is odd electron molecules that I have already covered, that is nitric oxide NO. Okay, their total number of electron were 11, here total number of electron is 17. So let us see the structure of NO2 first. So okay dear cadets, now nitrogen dioxide and nitrogen tetroxide. So nitrogen dioxide it is monomer of N2O4. This is stable in gaseous state. What is this one? This is stable in gaseous state. In solid and liquid state, its dimer is stable. And what is the dimer? N2O4. NO2 into 2 equal to N2O4. We'll tell about in detail as far as N2O4 is concerned. Just concentrate on this one. It is the odd electron molecules. Already I told you why it is the odd electron molecules. Because here 5 plus 12 electron, total 17 electrons are there. How many electrons? 17 electron. Just see. Because of presence of one unpaired electron, it is paramagnetic. And now to know about the unpaired electron, let us see the structure of NO2. Just see. NO2 total 17 electrons should be there. Around the nitrogen, how many electron is there? 5 electron is there. So just 2 are here, third is here, and now this oxygen is negatively charged. So this bond is purely formed by the nitrogen only, means 2 electron is involved here. So 2, 4, 5 electron. This is only unpaired electron. What is this one? Unpaired electron. And this is responsible for paramagnetic nature of NO2 and its instability also. Okay. So this is the first structure, this is the second structure. This is the resonating structure. Shift this bond here, shift these 2 electron here, so you will get this one. This is the resonance hybrid. Okay. So the most important thing is the presence of unpaired electron. Just see, in both structure this unpaired electron is present. In both structure, because of presence of one unpaired electron, it is paramagnetic. Okay, means NO2 is paramagnetic. And remember, NO2 is stable in the gaseous state, solid and liquid state. N2O4, its dimer is stable. Next one, because of presence of one unpaired electron, it is unstable and forms dimer. In dimeric form, both electron forms single bond and join both nitrogen atom. Its dimer is N2O4. Just see how the dimer is formed. Just try to understand. Take these 2 one of the structure you can take from here only. See, this is NO2. What is this one? NO2. This is unpaired electron. Now here I am writing. What is this one? Unpaired electron. What is this one? Unpaired electron. Okay, no problem. So this unpaired electron, see, this unpaired and this unpaired electron, both will come together and they will form single bond. Just see, here single bond is formed. Now in this way both are combining together. So now this is now N2O4. What is this one? N2O4. So now in N2O4, no unpaired electron is there. That is why N2O4 is stable. One thing. Second one, it is now dimagnetic. Why dimagnetic? Because unpaired electrons is not present. Unpaired electron, both unpaired electrons join together and they form N2O4. So this is the reason. That is why N2O4 is means stable and dimagnetic. Okay. So I hope that you have got. In NCERT book they have given one question. Why is NO2 dimerized? So NO2 is unstable because of presence of one unpaired electron. That is why it dimerizes so that it becomes stable. Because in dimeric form both unpaired electron combine together and form single bond and both NO2 molecules join together. So to get this stability, NO2 form dimer, that is N2O4. Here it is clearly mentioned. Okay, so this is also monomeric form, this is also monomeric form. Because of the presence of these unpaired electron, they combine together and form this one. So in this way, dimer is stable in liquid and solid state. In this way, your NO2 is completely completed. Now its dimeric form is N2O4. So let us have some idea about N2O4 also. N2O4, dinitrogen tetroxide. Okay, this is the dimer of NO2. This is also known as nitrogen 4th oxide. So just see, 2NO2, that is equal to, this is monomer. Okay, monomer. What is this one? Dimer. Okay, so just see, NO2 should be cooled up to 250 Kelvin, then only you will get. If you heat this one N2O4, then you will get this one. So just see, heat is required, that is why it is stable in gaseous form. What is this one? Gaseous form. And this is stable in liquid or solid form. Okay, so just see the property. If this is one of the property only, N2O4, what is this one? Colorless. If you are heating up to 415 Kelvin, then you will get the reddish brown color gas, that is NO2. What is this one? Reddish brown color gas, NO2. Now same gas, if it is cooled up to 250 Kelvin, then you will get N2O4. Means what is there? There is one temperature, the temperature between 250 Kelvin to 415 Kelvin. Both forms exist. This is the equilibrium. What is there? When you cool, then N2O4 is stable. When you heat, NO2 is stable. Are you getting my point or not? In cooling condition, N2O4 is stable. Okay. At higher temperature, which is stable, NO2 is stable. Okay, that is why I wrote here at between 415 Kelvin to 215 Kelvin, both forms of nitrogen tetroxide exist. Here I wrote exist. Please check this one. This is exist. Okay, so there is the equilibrium between N2O4 and NO2. In less temperature or cooling condition, N2O4 is stable. At higher temperature, NO2 is stable. And this is the resonating structure of N2O4. Okay, so if you go through this one, since I taught you all the resonating structure of oxides, and 11th class also in the detail we have studied the resonating structures, so very easily you will come to know. Here also positive sign is there. In just see, if nitrogen is acquiring positive sign, so one of the oxygen out of two will have negative sign, that is there. And this is the resonance hybrid. So resonance hybrid between this N and O bond 121 picometer bond length, and NN bond length is 175 picometer. This bond angle is 135. Remembering bond length and bond angle is difficult, I know, but if you practice, then you can remember it. Now method of preparation, this is very famous method. Okay, lead nitrate. What is this one? Lead nitrate. When you heat the lead nitrate, and this reaction you are studying since 10th class. Okay, in 10th class also this reaction is there. Decomposition of lead nitrate, then reddish brown color NO2 gas you are getting. NO2 gas you are getting. Two gases are formed. One is oxygen and another one is NO2. This is the laboratory preparation of NO2 gas. So reddish brown color gas is produced due to decomposition of crystal structure of lead nitrate. See, if you have taken the salt of lead nitrate in the test tube, in the laboratory you are doing the salt analysis. So if salt analysis, lead and nitrate, salt you have taken. So first, what is in preliminary test, what you are doing? You are heating lead nitrate, salt. So when you heat the lead nitrate salt, what is there? Crackling sound is produced. What is produced? Crackling sound. Why crackling sound is produced? Production of crackling sound itself justify that the given salt is lead nitrate, and there is no requirement of further test. Crackling sound is produced because of the disintegration or breaking of lead nitrate crystal. Remember this one. Crackling sound is produced because of the breaking of lead nitrate crystal. So in this way N2O4 is completely completed. The last one oxide is N2O5. This is dinitrogen pentaoxide and nitrogen fifth oxide. Nitrogen fifth oxide. How you will prepare? Very simple thing is there. Method of preparation. Just see. Take HNO3, 2 molecules of HNO3. It should be treated with P2O5. P2O5 is very good dehydrating agent. What is this one? Very good dehydrating agent. Then HNO3 will produce N2O5 and metaphosphoric acid, that is HPO3. What are the physical property of N2O5? Acidic nature, oxidizing agent. Okay. Now to prove the oxidizing character, this reaction you can write. If you heat N2O5 less than 273 Kelvin temperature, then it will produce NO2 and 1 nascent oxygen. So production of nascent oxygen itself indicate the behavior of oxidizing character. Okay. As far as the resonating character is concerned, as far as its structure is concerned, their structure is very much similar with N2O4. Only one difference is there between this nitrogen and this and this. Put one oxygen. Now structure is ready. So I hope that you can prepare it very easily. Just see, it is like that. Just see. NON. One double bond, one single bond. Here 2, 4, 6 negative sign. Here what is there? 2 and 4 electron. Similarly here this oxygen, what is there? 2, 4, 6 and negative sign. Here what is there? Double bond. What is there? 2 and 4. Okay. So now here what is there? All the electron of nitrogen is involved. 2 electron here, 2 electron here, because oxygen is negatively charged, and 1 electron here. So here positive sign, here also positive sign, and this oxygen will have 2 lone pair of electron. Now second resonating structure can also be prepared. Shift this bond here, shift this bond here, shift this one here, like that and like that. Here also shift this electron here and shift this one here. So you will get the next resonating structure. I hope that you can prepare this one very easily. In this way the oxides of nitrogen is completely completed. And N2O5 is basically used as a oxidizing agent. It is used in the rocket, as in rocket fuel, as a oxidizer. N2O5 is used as a oxidizing agent in the fuel of rocket. Okay, just remember this one. It is oxidizing agent or oxidizer. So I hope that I have covered the application part also. NO application I told you. There is one more aspect, that is the ring formation test. You are for the confirming the NO2 ion. Ring test you are doing or not? So the chemistry of ring test I will teach you in D block elements, because there is one aspect you cannot understand without understanding that concept. So I will wait till the arrival of D block elements. Okay, in D block elements, even if you will forget, I will not forget, and definitely I will complete. So chemistry of ring test, that is the confirmatory test for the nitrate ion, NO3 single negative ion. That is there or not? So confirmatory test of nitrate ion ring is formed. That I will teach in the D block elements. Purposely I will teach that time only. In the ring test, what you are doing? Just see. You are taking the freshly prepared solution of FeSO4. Okay. And nitrate salt itself. Okay. Nitrate salt aqueous solution. So in the aqueous solution of nitrate salt, you are adding the freshly prepared solution of FeSO4. What is the oxidation state of iron in FeSO4? +2. Okay, then with the help of wall of test tube, you are adding the concentrated H2SO4. So where both liquids meet at the juncture of concentrated H2SO4 and the solution of nitrate, salt and FeSO4, one brown color ring is formed. Which color ring is formed? Brown color ring is formed. Okay, that is the confirmatory test. Formation of brown color ring indicate the presence of nitrate salt. Now this is the theoretical aspect. What is the equation? Why ring color is formed? Everything will complete in the D block element. So dear cadets, now oxo acids of nitrogen. There are two types of acids. One is the Hydroacid, second one is the Oxo Acids. So what is the difference between Hydroacid and Oxo Acids? Hydroacids contain hydrogen only. Oxygen is not there, like HCl, HBr. These are Hydroacids. Okay. What about Oxo Acids? Oxo Acids are those acids which contains oxygen in addition to the hydrogen, like H2SO4, HNO3. These are oxo acids. Okay, so in our syllabus what is there? Oxo acids of nitrogen is there. Okay, so there are three types of oxo acids of nitrogen. One is the nitric acid, HNO3. Second one is the nitrous acid, that is HNO2. Yesterday only I have discussed many things about the HNO2 and HNO3. HNO3 is only oxidizing agent. It can't be the reducing agent, but HNO2 is oxidizing agent as well as reducing agent. Okay. Another one is hyponitrous acid. This is completely unstable. What is there? Completely unstable. Okay. This is partially stable. Which one? Nitrous acid. And nitric acid is completely stable at room temperature. Whenever we are talking of stability, it means we are talking about the stability of that compound at room temperature. Okay, above and below the room temperature we are not talking. Okay, so all these acids, nitrous acid and hyponitrous acid, they are stable only, but at room temperature they are not stable. HNO2 is stable partially at room temperature. Okay, but at higher temperature it is not stable. Okay, so the oxo acids of nitrogen, the first one is the nitric acid, that is only in the syllabus. So now HNO3. Okay, nitric acid. Okay, so here oxidation state of nitrogen is +5. So now the first method, means the first thing comes into mind is method of preparation. So see the method of preparation of nitric acid. Method of preparation. So method of preparation, just see, we have already discussed this reaction. Once again I am discussing. NaNO2. What is this one? Sodium nitrite. Always remember, NO3 is nitrate. What is this one? Nitrate. And NO2 single negative, this is nitrite. What is this one? Nitrite. So NaNO2, that is sodium nitrite, it should react with H2SO4. What should be the nature of H2SO4? It should be dilute. If it is concentrate, then reaction won't be there. Sorry, it should be concentrate only. If it is dilute, then reaction won't be there. Now here one of the important thing. Temperature should be less than 500 Kelvin. It should be near about 423 Kelvin to 475 Kelvin. Means without fail temperature should be less than 500 Kelvin. Then what you will get? You will get NaHSO4. NaHSO4. Another one you will get HNO3. Okay, HNO3 plus what you will get? H2O. You can balance the reaction also, there is no issue. I think reaction is balance only. Water is not formed. Yes, water is not formed. Okay, so check now. 2 oxygen, 6 oxygen should be there. So now this side what is there? 7 oxygen is there. It means balancing is required. This is NaHSO3. Yes, now it is balanced. 4 to the 6. What is the name of this one? Just remember this one. SO3 2 negative. What is this one? Sulfite. What is this one? Sulfite. Okay. SO4 2 negative. What is this one? Sulfate. Sulfate ion. What about this one? HSO4 single negative. This is bisulfate ion. Bisulfate ion. This is also known as hydrogen sulfate. Hydrogen sulfate. Okay. Next one is HSO3 single negative. This is hydrogen sulfide. Hydrogen sulfide ion. This is bisulfate ion. This is hydrogen sulfide ion. Okay. So just see. What is the name of this one? Sodium hydrogen sulfide. Sodium hydrogen sulfide plus HNO3 is formed. Now suppose temperature is above the 500 Kelvin. Then see the reaction. See. NaNO2 plus conc H2SO4. Now suppose temperature is more than 500 Kelvin. Then here what will be formed? Na2SO3. Okay. Plus HNO3 is formed. Dear cadet, just see here, this is not a sodium nitrite. This is sodium nitrate. Okay. What is this one? Nitrate salt you have to take. NO3 single negative. So here what would be there? NaHSO4 plus HNO3. Rest everything is same only. Here also you take. So what I was telling you, if the temperature is beyond 500 Kelvin, then here what is there? Na2SO4 plus HNO3 will form. And this Na2SO4 form scales. What is there? One flake like structure. Okay. One layer it will form. Either at the bottom of test tube or weaker, and that will consume more heat. So what would be there? Weaker or test tube will be broken. Okay. So that this is the reason, means due to the formation of Na2SO4, scales will form and resulting into breaking of test tube. So what is there? Be avoid to keep the temperature beyond 500 Kelvin. Are you getting my point or not? It should always be less than 500 Kelvin. Now if less than 500 Kelvin temperature is there, so then sodium hydrogen sulfate will form. Sulfate. Okay. What is the difference between sulfite and sulfate? In sulfite, the oxidation state is +4 and the oxidation state of sulfur is here +6. That is the only difference. Okay. Sulfite means SO3 2 negative. Sulfate means SO4 2 negative. Okay. So just remember this one. That is why we always avoid to keep the temperature beyond the 500 Kelvin. It should always be less than. And this is laboratory preparation. What is this one? Laboratory preparation. Okay. Now in commercial scale, HNO3 is prepared by the Ostwald method. Which method? Ostwald method. Dear cadets, whatever nitric acid is formed by this method, actually it contains some contains some water. Okay. So it should be distilled with or dehydrated with P2O5. So P2O5 is here dehydrating agent. Dehydrating agent. Okay. So in this way the laboratory preparation is over. Now next method is Ostwald process, that is for the large scale production of nitric acid. So dear cadets, as far as the large scale production of HNO3 is concerned, it can be prepared by Ostwald process. Okay. So for the commercial scale production of HNO3, we use this one. So now how many steps are there? Just see. Steps number first, that is the catalytic oxidation of ammonia, catalytic oxidation of NH3. Okay, in this step what is there? Ammonia should be oxidized in presence of platinum or rhodium, that is RH. Then you will get NO plus H2O, NO plus H2O. So now do one thing, write down here 2, write down here 2, write down here 3. So oxygen is not balance, oxygen is not balance. We can balance the oxygen, there is no issue with this one. 4NO, we will take here 4NO. Okay, so now here also you have to write 4NO. So hydrogen is 12 now, so here take 6. So now here 5. Okay, now everything is balanced. Okay, so now in catalytic oxidation of ammonia, what we have got? This is PT or ruthenium gauge. Gauge means you can understand, mesh, net like a structure. And here 500 Kelvin temperature should be there and pressure should be 9 bar. Okay, so you have got NO, nitric acid. So now in step number 2, what we will take? As you know, NO is stable. So atmospheric oxidation of NO. In oxidation of NO plus O2. You know NO is unstable. This is also odd electron molecule. So one unpaired electron is there. So when you oxidize this one, it will form stable form. This is unstable. What is this one? Unstable. And what is this one? This is stable. Okay. So write down here 2, write down here 2. So 4 oxygen, 2 nitrogen. Everything is balanced. So now oxidation of NO. Okay. So when NO is oxidized, the more stable form is formed. That is NO2. Now third one is dilution with water or reaction with water. Reaction with water. So just see. NO2 plus H2O. So here what is there? HNO3 plus NO will form. What is formed here? NO. You take this one 2. Okay. So now here 3NO2. Now see. Everything is balanced. 3 2s are 6, 7 oxygen should be there. 3 2s are 6 plus 7 oxygen. Nitrogen should be 3. Nitrogen is 3. Everything is balanced. Now this NO is regenerated. Here you can write regenerated. So when it is regenerated, again it can be used in the second step. Same process it will continue. Okay, are you getting my point or not? This is NO is regenerated, which again will be used in the oxidation of NO. Okay, so now whatever HNO3 you have got here, okay, HNO3 you have got, this HNO3 is mixed with water. It is dilute HNO3. Okay, sometime we need concentrate HNO3. Then how can you will get the concentrate HNO3? Very simple method. Form HNO3 can be concentrated by distillation up to 68% by mass. Okay, just see. This HNO3 is dilute. So distillation. What is the meaning of distillation? Meaning of distillation is evaporation plus condensation. Okay. So time and again you use the process of distillation till the mass of HNO3 reach to the 68%. Okay. Now try to understand, whatever HNO3 we are using in the laboratory, that is only 68% by mass. Okay. Beyond this one, you cannot concentrate HNO3. Why? Because HNO3 will form azeotropic mixture with the water which is already associated with the HNO3. Are you getting my point or not? It will form azeotropic mixture. What is the azeotropic mixture? In solution chapter, azeotropic mixture you have studied. Azeotropic mixtures are those mixtures which boils at constant temperature without decomposition. Means here HNO3 and H2O both will boil at the same temperature, constant temperature, without decomposition. Okay, without decomposing. Okay, are you getting my? So here components are two. One is HNO3 and H2O, another one. So just see, both should boil at a different temperature, na? But the moment the percentage of HNO3 is 68%, then what it will do? Now it will form azeotropic mixture with the water. So azeotropic mixture is the mixture which boils at constant temperature without changing its composition. Means you keep on boiling, but whatever temperature you are giving at distillate, both HNO3 and H2O both will be present. Means water will not leave the HNO3. Okay, the moment you reach to the 68% by mass. Okay, then what is there? Suppose you want more percentage of HNO3. Okay, so to get the 98% HNO3, it must be treated with concentrate H2SO4. Okay, now try to understand. Still with the HNO3 water is there. So you do one thing, that reaction mixture should be added with concentrate HNO3. Concentrate HNO3 is very good dehydrating agent. So it will absorb all the water which is associated with the HNO3. Now again you start the same process, distillation. Now this time what is there? Water is not there. So no one is there to form the azeotropic mixture. So now you will get the HNO3 whose percentage is now 98%. Okay. So generally we do not require 98% concentration HNO3. We require only 68% concentration of HNO3. And the laboratory we are using 68% concentration of HNO3. Okay. In this way, this was the commercial process that is also completed. Thank you.